Alright, this should look very similar to yesterday's problem where we did volume-volume calculations, except here we're going to do volume-volume calculations or volume-mole calculations, and we're actually going to treat this as a limiting reactant question. So how do we distinguish this from yesterday's question as being a limiting reactant question? First of all, we see that there are two volumes. If we think back to grade 11 when we had two masses of reactants, we had a limiting reactant question. We have two volumes of solutions, reactant solutions. We also have a limiting reactant questions. So yesterday we took our first volume in liters, multiplied by its molar concentration, molar ratio between the two substances, in this case the first reactant and our precipitate that we're looking for its mass, and we calculate the number of moles. I'll explain why we're calculating the number of moles here in a moment. Then we take our second reactant in its volume, multiply it by its molar concentration, again a molar ratio with the first reactant and the precipitate, to get the moles of our precipitate once again. Now last year, where the mass of the precipitate determined the limiting reactant, the lowest amount of grams. In this case, we can do the same with moles. Moles is an amount just like mass. So in this case, we take the moles of the mercury 2 sulfide, the smallest amount, and this indicates our limited amount, the amount that we'd expect to receive based on our limiting reactant, which is sodium sulfide. So we take the moles of our product, our precipitate, and we can convert that to grams. It does save us a few calculations, and there's our final answer that we would expect to get. And we will leave these in moles here, and we'll do some things with those later, but this is a way to treat these questions, these limiting reactant type questions.